Okay, I am going to beat this horse until it's dead. That's not quite the correct expression, but I don't care. We're gonna do this some more because you've got to know this. It just makes life so much easier. Okay, so any of the crosses in the preceding slide, or preceding video in this case, can be combined. So you can do that and get that. That's really common, actually. That's multiplying both sides of the equation by BD. If you want to think of it that way, for some crazy reason. Okay? You can do that. Right? Numerator on the left, on the right becomes denominator on the left. Denominator on the left becomes numerator on the right. Right? Divide on the left becomes multiply on the right. Multiply on the right becomes divide on the left. It's kind of like adding on one side becomes subtracting on the other side of the equation. This only works with an equation in between. Not if you're adding these two fractions, you can't do it this way, okay? Only with the equals. So you can do those three. And you get this. Make sure you can see what I did there. It's really simple. You're just moving stuff around. But it's also a really important principle. This fact that division on one side of the equation becomes multiplication on the other side of the equation, and vice versa. That's actually a really important concept. Now look, I did all four of these buggers. All four at the same time. And I've seen all of these combinations happen before. Like, so there's good reasons to do each one. Okay. Why would I want to do just that one? Because I want to solve for x. So first I want to solve for the factor on the left that contains the x, which is x minus 3. Right? The factor of 1/2 is the one I want to get rid of. So I just move the 2 to the numerator on the other side of the equation. And this is a proportion, right? Fraction equal fraction. And now I can move the 3 to the right and make it a plus after canceling. Right? Which is how I got that. Subtraction on the left becomes of the equation becomes plus addition on the right. Times on the left becomes divide on the right. Divide on the left becomes multiply on the right of the equation. So this cross multiplying is kind of related to this moving terms from left to right on the equation, which I do all the time as well. It's just the cross multiplying has to do with multiplying and dividing, and the other has to do with adding and subtracting. Okay, why would I do this? Why would I do this, or this type of cross multiplying? I crossed three things. Because I want the x's on top. They're just easier to solve for if the x is in the numerator. So that's why I'm moving the x minus 1 to the left side, to the left numerator. Then I'm going to want to solve for x eventually, so I might as well get rid of the divide by 2 and the times 3. So I move them to the right side of the equation. Since the x is going to the left, I'm getting all those constants to the right of the equation. So I get that right away, boom. Look at that for a while. And then I just add 1, or I just move the 1 to the other side, it becomes plus. And of course I want to write that as a single fraction, which would be 5/3, right? Okay, so this is super, super useful. So I want to make sure that you get, because this is how, if you can't follow what I'm doing, when I'm doing algebra, most of the stuff I'm doing is exactly these things.